Welcome everybody to this afternoon's webinar. This has proven a very popular topic. We've got nearly 300 people that have registered for this afternoon's webinar. You're very welcome. We're going to be spending about the next hour learning about an introduction to solar panels on churches, looking particularly at solar PV panels, the kind that make electricity rather than solar thermal. Let me move ahead. We always begin with a preview of upcoming attractions, and we've got quite a varied range of webinars coming up over the next few weeks and months. So tomorrow we've got a webinar on preaching for God's world with a really interesting panel drawn from around the world, from Brazil, Kenya, Polynesia, the UK and the USA, helping you think about how to include the environment in your preaching. Then we're on to the rather more prosaic but important subject of church heating. So we've got our topic 1, to replace or not replace, the second run of that coming up in May, and then the first and second runs coming up of topic 2, choosing the right heating solution. Then in the middle of May, we've got a session that's themed around the Great Big Green Week and how you can use the Great Big Green Week to help you engage your local politicians in climate action. And then at the beginning of June, we're into Church's Count on Nature, that first full week in June, when hopefully many of you all around the country will be going out into your churchyards and recording the precious biodiversity that you find there. And we've got our 5 different webinars themed around land and nature. So the one on the Monday on churchyard management, on the Tuesday, a panel of really good examples from around the country. On the Wednesday, paying attention to nature with our lead bishop on the environment, Bishop Graham Usher. The Thursday is a speaker from Russia who run the Eco Church program, and they're going to be talking about the land section of Eco Church. And then on Friday, we're finishing with the big picture, talking about global to local, tackling the twin crises for climate and nature. That's an update of a previous webinar that Pete has run for us, and I really recommend it. It's so useful and so fascinating. Coming into June, Guy will be repeating this webinar again for us. So if you leave today thinking, oh, I didn't catch everything, or I'd really like some colleagues to come along to it, you can let them know they can come along in June. And just an early flag that in October, we're rerunning our heat pump training. That's not a webinar, that's a whole day. If heat pumps are something you need to understand better, do come along to that training in October. It's the usual housekeeping today, so please type your questions into the Q&A rather than the chat. After the webinar, I will send everybody the slides. We are recording. Oh, and I'll also send you any links from the chat. So if you see links being posted into the chat, don't feel you have to grab them all. I will send them to you after the webinar finishes. And we are recording today's webinar, and it will be shared both on our website and in our YouTube channel. Right, now most importantly is to introduce Guy, our speaker today. So Guy is from the accredited solar installer Treadlighter and is very, very experienced in what it takes, the realities of doing solar installations on an incredible range of buildings. Done over 1,000 installations, and including in that residential, universities, churches, perhaps most importantly for us today, and halls of different ages, different listings, huge range of experience. Whilst Guy is from one particular installer, I have briefed him and he fully understands today is not a sales pitch for Treadlighter. It's learning from Treadlighter's experience, generic information that could help you move forward your project at your church with whichever installer you decide to use local to your area. And if you haven't come across me before, Catherine Ross, I am the Net Zero Carbon Senior Project Manager, and I'm part of the Church of England's Environment Programme team. So let me stop sharing my slides, which means that Guy can share his and take us away.
Lovely, thank you very much, Catherine. Let me share my screen. Good afternoon, everybody. Let's make sure that this works. So can everybody see this now?
That looks perfect, thank you.
right? Is there some reason I've got the...
Well, that's working for us. We can
Is
see
that
the
working?
slide.
Everybody can see?
Yep.
Okay.
We've got now the early history of solar.
Right, perfect. Okay, let's start. Tiny bit of a history lesson to begin with. Not a lot of people realize that the photovoltaic effect, that is effectively the creation of electricity from daylight, began a long time ago now, coming on for 200 years ago. The French research physicist this is how the legend goes, was experimenting with an electrolyte solution in a glass vessel with 2 electrodes at either end. And he was trying to see if there would be any electrical activity going on. And he tried for a long time, and eventually he went to bed one night and he'd forgotten to draw the curtains. And when he got up in the morning, the sun was streaming through, and there was a very small electrical charge being recorded between the 2 anodes. That was the start. It took about 120 years until, about 65 years until Albert Einstein actually explained exactly what was going on with this photovoltaic effect. And it wasn't until the mid-50s that the American company Bell unveiled what they promoted as a wafer of silicon called a solar cell. And by the late 50s, solar PV panels, albeit of very much lower wattage than now, were being used in the telephone industry, but also they cost a great deal of money, and they were the forerunner really for the space race, where every single satellite that is circumnavigating the planet has a solar panels on it, which charge the batteries, which keep everything working. So by the 1970s, it was down to about $20 a watt. Now we're in the pence per watt. And by the 1990s, we were starting to see solar panels being used outside of very specialist military and space operations, if you like. So at the moment in the UK, and these are figures that I checked actually yesterday, they're accurate up until the 31st of March, and they're from the UK government DBIS and their specific Department for Energy Security and Net Zero. We have just under 1.3 million PV installations on buildings in the UK. That's across the board. 146,000 installations last year, which I'm happy to say is the largest increase since 2015. Now, some of you may know that the government introduced back in 2010 what they called the feed-in tariff, which paid people for generating their own electricity. It also paid a small amount that was deemed to go to the grid. And the reason they did that was to get the market moving, to get people into this technology because of the great benefits that would ensue. As time went on, of course, the cost of the equipment started to come down, and therefore the incentive wasn't required, and that incentive was actually removed in 2019. And I'll come on to talk a little bit more about the effect of that later. We still have a situation that 98% of all solar PV systems that are installed in the UK are less than 50 kilowatts. That means the majority are on domestic properties or commercial buildings, of which a church would be considered a commercial building, and less than 50 kilowatts. So 50 kilowatts, if you look at 40 kilowatts, about 125 panels or so. Last year, I'm pleased to say, solar, wind and hydro reached a record high in its output in the UK. You would expect that as the amount of PV, the capacity increases year on year. And 41% of our annual requirement did actually come from renewables, which is great. And we did have a very good summer last year in part, but actually in June 2020, we had a period of 67 days where the country didn't burn any coal for the first time since the Industrial Revolution. So we're making steps. They're good steps. There's a lot more to go. So what is solar PV and how does it work? Well, in broad terms, a solar PV panel generates electricity from daylight. I thought that was quite cool, which is one of the reasons I retrained. And started a business in this sector. So contrary to what a lot of people think, they actually work on cloudy days as well as sunny days. They don't work as hard on a cold January day, but you will get something out of them. As the sun moves back into the northern hemisphere after the vernal equinox, of course, the amount of daylight is greater than the amount of nighttime. And so the sun is higher in the sky, the incidence of irradiation is greater, and therefore the panels and systems will output. And in broad terms, you get about 75% of your annual output in what we call the 8-ish summer months. So the winter months would be November, December, January, February, and the shoulder months would be October and March. System sizes is very straightforward. It's the wattage of the panel multiplied by how many panels. So 50 panels at 300 watts is 15,000 watts divided by 1,000. That's a 15 kilowatt peak system. And the peak, really, don't be confused, it stands really for the absolute peak output of the system at any one given time. But it'll never reach that because there's always a few losses in the cabling, in the inverters that are completely unavoidable. It's a very robust technology. There are no moving parts at all. It's one of the few, if not the only, renewable technology that doesn't have any moving parts. You get very, very good warranties. Almost every single panel manufacturer now is 25 years and some are 40. And the vast majority of systems, unless they're very big, only require an annual test, check and inspect just to make sure that the system is operating okay and it's safe. So in that regard, you know, they're great. It's a great technology. Now, your typical system setup, without going into too much detail, is panels on the roof, however they may be, whether that's flat, inclined, or whatever. An inverter, the panels produce DC, which needs to be converted to AC for use in a building. Just like when you plug into the wall, that's what you want, is AC. So the inverter converts that to AC. You have some isolators, a meter that records what the system generates, and then we grid connect it into the distribution board in the building. That means that anything that is connected to that distribution board that requires electricity can use the solar electricity. So it's not just defined to any specific circuit. So briefly, without going into too much detail, solar panels now they've almost doubled in their wattage output since we started installing at the end of 2009. We were starting with 195, 200 watt panels, and they're now 400 watts plus, and they're going up. But the physical dimension of the panel remains broadly the same. So what that enables you to do is to install more capacity in the same space. Panel optimizers may be used if you've got panels that are going to be intermittently shaded. You then have DC cabling from the panels to the inverter, AC cabling from the inverter down to the supply head. And quite often we find that the inverter might be in the bell tower, but the actual distribution head is perhaps in a crypt or it's in the ground floor of the building. PV meter, a meter that records everything the PV system generates. That's all it does. We grid connect it to the building so that any solar electricity can be used by any circuit connected to that board. So what's the environmental benefit? Well, when you have a PV system, it's like having another grid on your roof. And one way in your distribution board is effectively another grid. So when it's daylight, the system is generating, and the building will always use the solar electricity before it buys anything from the grid. So what you have at the moment, if you don't have a PV system in your building, is you have an electricity meter, but that's known as an import meter. It just measures what you buy from the grid. Okay, the meter we put in just records what the PV system generates. Now, if you're using, so let's suppose your building needed, for want of argument, 1 kilowatt instantaneously. You've got a few things on, that's what it needs. and the system is producing 1 kilowatt. Well, at that point in time, you are not drawing anything from the grid. You are self-sufficient. You are providing enough electricity. As soon as maybe a cloud goes over, the output of the PV drops slightly, then you will only pull in the balance of the electricity. And so what that means is that over a period of, this is happening all the time. It's literally happening all the time. And what it does is over a period of time, it reduces the amount of electricity the building needs to draw from the grid. And in doing that, it reduces the electricity bill. And because it reduces the amount of electricity you need, there is a carbon saving because a tiny bit less coal or gas needs to be burnt in order to provide you and transmitted to provide you with the power that you need. So by reducing the CO2 emissions, a PV system helps to protect the environment. It also improves the energy performance certificate rating for a building, or if it's a public building, the display energy certificate. Because anything you do that offsets the amount of carbon the building emits gives the building a better rating, which is what we're all after. Ideally, we'd all like buildings that are completely carbon neutral, and that's where we're going. But that is jolly difficult to do with some churches, of course. Question we often get asked is, well, that's all very well, Guy, but how much energy does it actually take to make a solar panel, and will it ever pay for itself? Well, there've been a couple of studies done on this. I won't go into too much detail, but the rule of thumb is that the amount of energy that is used to make and transport a solar panel takes a little over a year in order to pay back, if you see what I mean. So what's a financial benefit? We all like to do things that please our head and our heart at the same time. If you reduce the amount of electricity that you're using, you reduce your bill, and there is a saving to be made. You can also be paid for any electricity that flows out to the grid. Now, I may add that let's say you had 10 kilowatt peak system on the roof, you only need 5 kilowatts, so the church is running for nothing, or the church buildings. So what's happening to the other 5 kilowatts? Well, it instantaneously flows back out to the grid, and it can be used by anything in the local environment, local area. So it's only right that as an owner of the system, where you've invested in the system for all the right reasons, that you should be paid for that. And you can be paid through your electricity provider any electricity that is exported to the grid. And I'll come on to explain that in a little bit more detail. In terms of return on investment, yes, it's good to do something that makes sense financially as well as in the heart. And we're finding that particularly now, because of the substantial increase, sadly, of grid electricity costs, that we can see some very, very high return on investment figures as a percentage. A lot of it depends on accessing the roof. The system cost is one thing and the engineering cost, but it's getting up there to do the work safely that can be an expensive item. The other thing is, because a PV system generates during the daytime and grid electricity is generally more expensive in the daytime, if you have a church that connected to that supply is perhaps a church hall or some offices or buildings or whatever else is going on, self-help groups, AA, all sorts of things we've come across, the more electricity you use in the daytime, grid electricity, the more of the solar electricity you'll use, because your demand is higher, so you're more likely to use everything that the PV system generates. And that, of course, if one's now paying somewhere between, well, we've heard of horror stories, but somewhere between 40 and 85 pence a kilowatt hour, for every kilowatt hour you use from your solar, you're saving yourself quite a considerable amount of money over the year. Let's talk a bit about the Smart Export Guarantee. The feed-in tariff ended on the 31st of March 2019, and it was replaced in early 2020, at the beginning of 2020, with what's called the Smart Export Guarantee, which enables owners of micro generators that's under 5 megawatts, so don't worry, that's thousands of panels, to be paid for electricity that they generate, they don't use, and automatically flows to the grid. And those payments are made through your electricity provider. Once the system is installed, you have all the right paperwork and you can prove that it's been done by a properly qualified, accredited installer, which of course you will be able to do. In order to be paid for the electricity, you have to be able to measure it. Now, everybody is going to get a smart meter. Yeah, we're all laughing, but everybody is going to get a smart meter. The technology is improving. The second stage smart meters are much better. And a smart meter can record what you import and what you export. And so if you don't have a modern meter that is capable of doing that, then our understanding is that your electricity provider will come and change it for one that does. If you have a 3-phase supply to the building, the vast majority of 3-phase meters are already import-export meters. So just be careful that you check with that. Now, export tariffs, they used to be very low, but they've now been brought up, and we use an average of 12 pence. So for example, if you're paying 40 pence for what you buy in and getting 12 pence for what you send out, okay, it's better than nothing. It used to be 3 pence. So we think that this is going to go up, actually. It's only fair, really, that it goes up, and I can assure you that Ofgem are on the case. So that's how it works. You can be paid for what you send out, but you have to meter it. So let's move on now to talk about solar panels. Here's just a few slides and try to include a reasonable variety. Whoever you go to consider or to help you assess and specify solar must be MCS accredited. That stands for the Microgeneration Certification Scheme. And it is a mark of quality. People like us, we had it last week. We get an annual inspection. They go and see 2 or 3 of our jobs. We have all our paperwork examined to make sure, obviously, that we are advising people properly and the standard of the work is carried out is at the highest level. Panels now, as you can see on the right-hand side, the more familiar ones are the sort of light, dark blue with an aluminium frame. That's where they started. Aesthetics are a big driver, we find. Anything that is likely to be visible from the public highway, we would automatically recommend all black panels, particularly if you've got slate roofs, actually. They tend to disappear a lot better. Now, a popular misconception is that the panel efficiency, it primarily dictates the physical dimensions of the panel. Okay, so the vast majority of panels are 21% efficient, and they are in round numbers 2 meters by a meter, slightly shorter than that. There are some very minor electrical differences, some for very specialist applications like near the seaside with salt spray and whatever. Other than that, if it is a tier 1 approved product, a 400-watt panel outputs 400 watts. So they have become more or less a commodity. And I know you're all asking me the question, but yes, 90% of the world's production of solar panels comes from the Far East, not all China, but some in Malaysia, South Korea, Indonesia. Yes, a lot of the components, a lot of silicon factories are in China. Maybe they outsource the actual production of it. But everything that is available for use in the UK is approved by the BRE, the British Research Establishment, and by MCS itself. Every single product has to be approved by MCS. Okay, principal applications. This is St Augustine's Church in North London. As you can say, this is a chancel roof. There's a PV system, so we can fit onto solar panels can be fit onto existing roofs. One thing I would say is remember bird proofing. When you're looking at the expense of getting scaffolding put up in order to get up safely to install the panels, there's no certainty that pigeons or birds will nest underneath the panels. We can't see any rhyme or reason that they pick particular roofs, but when they do, they are a pest. They are diseased, they leave droppings everywhere, the young chicks, it becomes really messy and unhygienic. All of that can be very simply solved by putting a black mesh around the perimeter of the array to stop the birds getting underneath. We've never seen any birds start attacking the cables, but it's just the mess that they create. So do remember bird proofing. It is a little bit more of an expense because it takes quite a long time to do, and it can only be done at the very end, but it's absolutely worth it because you don't want to be spending the money putting the scaffolding up again. Flat roofs are very good. Most panels now, we would never really install more than 10-degree inclination, which takes them about just under 300 mil above the plane of the roof surface. As long as they're at 10 degrees, they will generate properly and they will self-clean to a very large degree. But the beauty of flat roofs, of course, is that you can move the panels around into any particular orientation that is the most favorable. In roof mounting, if you are re-roofing a building, we would suggest that you could consider in-roof panels, where no tiles are required under the panel. We use a specialist flashing system, and that sits the panels way down into the roof. And again, this is light grey tiles here, but if you had dark grey tiles, you can see how they will start to disappear and become significantly more aesthetic. And if you're lucky enough to have a piece of ground, you can even put them on the ground. And then a fence or a hedge can be grown up around the outside in order to. What we often get asked, particularly on slate roofs, is, well, how do you actually fit them? They're actually fitted to the battens and down into the rafters, which we find. There's very specialist types of roof hooks for all the different types of tiles. And what you end up with is a row of hooks running across the roof, and then the rails are bolted onto the hooks, and then the panels bolted onto the rails and electrically connected. Obviously, we tend to be the last people up on the roof, so we make absolutely sure that the roof is watertight before the scaffolding is ever taken down. Right, so that's a little bit on the sort of background of what solar PV is, how it works. It's really quite straightforward. I say it's straightforward. It's not straightforward in the design. Don't be fooled about that. Every building is slightly different, has different supplies. It's not quite that easy. You can't just, for example, add 3 more panels in the future because the inverter is specifically sized to the size of the array. So, right, let's move on to assessing suitability. What you see in the background there is a grade 2, I think it's definitely grade 2, maybe grade 2 star, can't remember, listed church in the middle of Chelsea, who are particularly difficult when it comes to planning consent. Now, many churches have an east-west aisle, so they generally have a large section of southerly facing roof. That's well suited for the generation, but it doesn't have to be. East-west is also really good. In fact, the shallower the roof, you can even put them on a north-facing roof. Up to about 10, 12 degrees, they will work. You won't get as much as the south side, but they will work. A lot of churches are old, Victorian or before. They're listed, they may be in conservation areas, often a feature of the local amenity, and have slate roofs. And would you believe that we quite often find roofs that are 80, 90 years old? And a lot of churches have had different types of supply and metering added over the years. And I'll come on to explain why that can be a bit of an issue, apart from the cost, because we've seen one church that had 3 different supplies. So they're paying for 3 standing charges, 3 different rates. So if you like, consolidating that into one supply is actually a very good idea, particularly if you're going to have solar, because we want all the solar power to be back to one supply head, 1 meter, 1 distribution board, so that everything that is connected to it can benefit. So what have you got to consider? Well, is it listed or unlisted? Is it in a conservation area? Is the roof, or are there sections of the roof that are relatively unshaded? Now, a little bit of shading is fine because we can use an optimizer on the panels. Effectively, PV panels don't like to be shaded. Now, if we see that 3 or 4 panels are going to be shaded intermittently as the sun, for example, passed behind the spire, it might cast a shadow over some of the panels. We would specify an optimizer for those panels, because a bit like a string of old Christmas tree lights, if one goes out, the others go out. But with PV, is if one panel is shaded, all the other panels that are connected in that string will only operate at the value of the lowest common denominator. So by adding an optimizer, think of it as taking that panel out, allowing all the others to operate properly. East and west is good, as I've said. And then critically, but not a deal breaker, are any of the potentially suitable roofs invisible from the public highway? I don't believe that we have had a church that required planning consent, aside from the faculty, obviously, that has been refused where the panels were invisible. I think there's a very hard case to make against that. The council would have to make a very, very hard case. And the other thing is the roof in good condition? Solar panels, if they're well looked after, 30, 40, 50 years or more, they're going to last for. So you wouldn't really want to be putting solar panels on a slate roof that's been there 85 years and got 365 replacement tiles in it. That may be the time to consider a bigger project where you may well be looking to replace the roof to get another 120 years out of it. And at that time, you could consider insetting the panels into the roof, because you won't need any tiles underneath. So what we find is the actual static load, most solar panels weigh about 20 kilograms, which is spread over the surface area of the panel, which is roughly 2 square meters. So the kilonewton force acting on the roof is not that great on an inclined roof. So we do find that in 99.8% of the time, adding solar panels is below the design limits for the roof, and that includes the past snow loadings as well. But I'll come on to talk a bit more about that. Critically, how easy is safe access? Do you require extensive scaffolding? Now, in a valley roof, you may just require a tower to get up there because you can't fall out of it. It's very difficult to fall off a valley roof. But if you've got a large south-facing section of roof that's 40 feet up with no parapet or balustrade, you are going to need significantly more scaffolding. Again, it's not a deal breaker. It just depends how you look at it. It depends how it's done. It depends what you're going to be able to get out and what benefit the church is going to receive, what ongoing benefit. All of that has to be considered when you're looking at the project. Something else that any installer will need to know, any designer and installer, which is how much electricity does the church use? Are there other buildings connected to the same distribution board, in which case we need to know what they use as well. And we need to know how much you pay for it, because in order to be able to work out some form of return on investment, we need to assess, well, any installer needs to assess how much of the solar electricity you are likely to use in the building as self-consumption, and how much is likely to go out, so that they can then present you and calculate for you and guide you in terms of what the benefits are financially, as well as carbon saving. Is there a high daytime occupancy of the church? We do a number of churches that have commercial operations going on. They've got offices, they've got nurseries, they've got self-help groups. Some have even got badminton going on in the daytime with lighting and stuff like that. So what is the occupancy of the church like? Does everybody close the door at 6 o'clock and go home, apart from one day of evensong? Or is the church only used twice? Lots of different considerations to consider. You don't necessarily want to be putting 25 kilowatts of PV up on a church that is basically used in the daytime, apart from one day a week in the evening. Another way to look at it is to say, well, say the church uses 10,000 kilowatt hours a year. If we generate 10,000 kilowatt hours a year, then we are technically carbon neutral on electricity. We are generating what we use. We may still get a bill because we might not use it all. We might be using electricity at night, not generating, let's say. But that's quite an interesting point to start with, which is, could we make ourselves carbon neutral for electricity? That may be a different driver. And then, very importantly, are any plans and elevations available for the property? If you need to go for planning consent, and we'll come on to that in a minute, and a faculty, you may well need to have plans of the building. And a lot of churches, of course, they don't exist because some of them were built 200 years ago or more. What about planning and consents? This is James Clerkenwell here, which one of the churches, that's a grade 2 star listed building. Right. Local planning consent and a faculty be required for any church that is listed or within a conservation area, period. If it's not listed or in a conservation area, you may be able to install under permitted development rules, and as list B, you should check with your archdeacon. A lawful development certificate is usually required by the DAC. So if you think you'd fall into the category of permitted development, it is better practice to get a lawful development certificate, even if it's not required, but you should get one because it's absolute proof that you're allowed to do it. Listed churches have an exemption from the need for listed building approval. The diocese will require a statement of significance and a statement of needs. And be aware that obtaining the consents can take anywhere from 3 months to more than a year. I think the longest we've had is just under 2 years. And that was a very, very slow council. And I think for more information, if you refer to national guidance, I'm sure Catherine will point you towards if you haven't seen already. We would strongly advise that if you need planning, that the services of an architect is very, very, hopefully you've got one within the parish or the community, but they are quite complicated applications, and it's useful to have somebody that really knows their way around, as well as the fact that they'll be able to prepare plans for you. And now there's all sorts of laser devices that can be used to create plans a lot easier than it was a few years ago. You need a heritage statement. Now, just because panels are or may be available, may be visible from the public highway, does not mean that it would not be accepted. You will need to make a good case that the public benefit outweighs the harm to heritage. Now, chances are the church is going to be there a lot longer than the panels, and the panels can be removed once their useful life has come to an end, but that may be some time. So in terms of drawings, you would definitely need a site plan. When you can buy that, it's quite straightforward, cost about £3.50. You'll need a roof plan, existing, and what you're proposing it's going to be. You'll need elevations that are existing and what they will look like. There's often very little change on that, particularly if the panels can't be seen. And then photos supporting the surrounding area. A heritage statement, history of the building, development of the building, its context in the local amenity, statements of significance, and an impact assessment of the proposed works. And again, an architect will be able to assist you with that type of document. We have seen people require a 3D model. Now, believe it or not, with things like Google Maps, it's become a little bit easier, but there are actually agencies that do have 3D models, but they can be quite pricey. It's not always required. I think I've only seen it once, but just bear in mind that may be something that you need to think about. Now, most importantly, there's no point to some degree putting PV on a building that's leaking, that's got a 50-year-old heating system and tungsten lighting burning a hole in the church's pocket and the environment. So it's very important that you really look and see what you can do to improve the efficiency of the building. For want of anything else, it means your upkeep cost is going to come down. I'm sure most people now are looking seriously and have already looked at LED lighting, but as a rule of thumb, LED lighting for the same brightness and color temperature of light is around about a 75 to 80% reduction in electricity use. Insulation, often extremely difficult in solid wall construction Victorian buildings. And the image on the right-hand side here, the actual volumetric space of their altar area there is larger than the average 5-bedroom house. So that's quite a challenge to light, but also it's quite a challenge to heat. And then you've got the rest of the church as well. Insulation can be extremely difficult and often not possible, but you are going to need to show that you have taken all steps and you can explain why you haven't. And then I saw on Catherine's introductory slide, heating critical and key. Again, it's only possible to do certain things, but you will need to demonstrate that you're taking it seriously and you're doing everything you can. Finally, any accredited installer of PV will be able to make a simple assessment of the roof capacity for accepting the load. However, you may well be asked to get that formally confirmed, and I don't believe there's many solar installers that carry structural engineers on staff, but you can find, if you don't know one locally, you can find them through CARE, which is the Conservation Accredited Register of Engineers, and you can expect to spend that sort of money if you need it. But as I said, the actual static loading is quite small on inclined roofs fitted to the rafters. Flat roofs, we would only self-ballast the panels on a flat roof. We don't go around puncturing people's flat roofs, and the aerodynamic mounting systems now are so good that it's computer calculated exactly how much ballast is required to keep it on the roof. Don't forget also cables. Wherever a cable goes, it needs to be on the plan, and it can be extremely frustrating to some degree. I've been at a church where I saw a lighting cable hanging off the parapet, going straight down to the ground and into the building. Yet we had to produce, 3 or 4 pages detailing exactly where the PV cable was going to be hidden. So that don't forget that this is where the architect will help you as well. Often we try to get the cable inside the building as quickly as we possibly can so that it doesn't affect the external appearance of the building. But as you can see, tucking it behind a drain pipe can often be, acceptable. Black cables used, things like that, just to try and make it disappear as much as possible. Fees, again, it can expect to pay somewhere from 2,000 upwards, depending on the size, scale, how much exists, how much doesn't exist, and what they've got to do. If you're looking at grade 1 listed, where plenty of grade 1 buildings churches that do have solar panels on them, could be a lot more complicated, that one. So you could be paying a little bit more for that. Okay, so a little bit there on what some of the things that you need to consider, and don't get frightened by it all, because the installer will be able to help you through quite a lot of these things. So let's look at the actual process, what's actually involved in it. Every accredited installer should be able to, will definitely be able to give you an assessment of what they think is possible using Google. It's incredible, Google, I have to say now. It really is. You can measure a roof on it, and with a reasonable degree of accuracy. And they should be able to give you a good enough assessment of what they think is the right type of system for you, because you will have given them the information that they need about your electricity usage. So they can do that without going there. That then gives you something to discuss internally with the PCC or whatever. And if you decide that, yes, this is something that you want to proceed with in principle, then they should come and do a site survey. My company makes no charge for doing that. I don't believe you should be charged for doing that. The purpose of the site survey is to look a little bit more closely at exactly what is required, to take measurements where it's safe to do so, to look at the incoming electricity supply and those types of facilities, and start to get a feel of exactly where things could be installed, what would be the optimum. And after that, they will be able to give you a pretty detailed idea of what they'd recommend for you guys to consider. Then you move through your PCC approval process, and then obviously there's the raising of the funds, which is something I can't comment on too much, but do look at local grants. There may well be some local grants available. I can't promise that, but do look at it. And then, assuming the decision has been made to approve and the funds, because they're going to be forthcoming, then you're looking at local planning consent, which we've just covered in terms of people to help you get that together. DOC faculty as required, as we already discussed. And then once you've got your permissions, then it is time to set a date for the installation and the site preparation. Any good installer will submit to you what they call the RAMs, a risk assessment and a method statement. Risk assessment's pretty obvious, and the method statement is this is how we are going to be installing your system, and this is the way we're going to do it. And obviously, if any scaffolding or lifting gear needs to be put up or edge protection, that would go up first, and then the installation can take place. And once the system is installed, it can be certified, and all the handover documents and paperwork given to you, along with any certificates, a building control certificate. And after that, there's periodic maintenance and monitoring. So that's the sort of stages. So what we've got here is St Mary's Hornsey Rise. You can see that in our opinion and the church's opinion, panels on the front roof were not going to be acceptable. It's a conservation area. But there are two buildings which are connected to the church on the same church supply and used by the church in the rear of the building. And they were of sufficient height that they weren't going to be shaded by the church all day. And so they could be used. Okay, so this was what we gave them to begin with. This is what we said, look, this is what we think is the best opportunity in order for you to benefit from solar. I'm not going to go through this in great detail, but this is just to give you some idea. We're looking at the azimuth, the way they face, the inclination of the roof, what panels, the inverter compatibility. We're looking at all the electrical engineering things that are behind the system, all the way through to operation and maintenance. Those are the things that any accredited installer is going to be considering when they make a proposal to you. They're looking at whether there's a lot of shading, how detrimental would it be? You know, quite often we get a situation where, well, we could add 8 panels there, but we're not going to, because if we advise the customer client to do that, those panels are going to be in shade for a great deal of time, and it's really not worth it. So sometimes it's better to have a smaller system that is unshaded than have a bigger system. Although it might output a tiny bit more, on a cost-benefit analysis, it's not necessarily the best idea for you. Then you will get produced a roof plan, which will show the broad layout of the system. Again, you can see the north indicator on there showing that this is actually the south-facing roof of the church. But again, east-west can work very well. The system output is calculated, the whole of the world actually now is split up into areas, almost postcode really, where the irradiation data, radiation is the amount of daylight energy hitting the surface of the planet, is recorded. And we use an average amount of solar irradiation over the postcode where you are, which is the basis for working out how much electricity the PV system is going to generate. So you can see on the chart on the drawing on the right-hand side here, obviously, as you'd expect, the southern part of the United Kingdom gets the largest majority at the highest intensity of irradiation, but solar panels still work perfectly well in Scotland. Absolutely. They're generally angled a little bit more, but they generally work perfectly fine. We actually get more than enough solar irradiation in a year to make solar panels worthwhile. If we didn't, there wouldn't be 1.3 million properties with them on. So then we're looking at, just to give, without going into too much detail, we've got the capacity of the system. The country is split out into regions. They're not like the postcode regions, you know, we all know, they're a different type of zoning. And then you've got the detail of the system, for example, the orientation of the array. We take 0 as being due south, minus 45 would be southeast, plus 45 would be southwest. Then we know the inclination of the roof. The roof is a 25-degree pitch. And then we can read off the table that for every kilowatt peak of PV, we are likely to get 919 kilowatt hours produced. If the shade factor is 1, it means there's no shading. And therefore, simple multiplication gives you the forecast output of the system. Now, for some reason, I've got 1 second. Right, better. Okay.
Guy, forgive me for interrupting your flow. I'm just conscious it's 10 to 5, and I know you haven't got to batteries yet. We've got a queue of questions.
I'll go.
If you can be speedier, please do, but without losing the wonderful content.
No problems. Okay, I just wanted to. Let me go. How can I get to the next slide? That's a bit annoying. I've just lost my. Okay. Here we go. Can everybody hear me still? Right, battery storage systems. There's been a lot said about battery storage systems. It's a simple concept. It's a simple concept. If you're producing more electricity than you need, you should store it in a battery and then you can use it when the sun goes down. Sounds simple, and it is simple, but you have to be careful. What a battery does is it increases your self-consumption percentage of the electricity that's generated. But the size of the system, how much electricity you use, and the occupancy are absolutely key in determining whether or not a battery is for you. If you're using all of the solar electricity in the daytime because you've got a high load, there's no point in having a battery because you're not going to put much in it. On the other hand, if you've got a church that does very little or virtually nothing in the evening, there's no point in having a battery because you've not got anything going on, so you don't really need to save anything. Often we find you put a PV system in and you can measure what is exported over a period of time, and that can inform your decision. So you need to be very careful. It's easy for people to be missold here. You need proper advice. Batteries at the moment are not MCS accredited. They are working on it at the moment. That just means that they aren't governed by a standard. It doesn't mean to say that a proper MCS accredited company will not give you proper advice, because they will. Be also aware, this is taken from the 1st of March to the 31st of March. This is the system on St. Paul's Church in Marylebone. And this gives you an idea of the output of the system, how it varies with the weather conditions on a daily basis. You know, on one day, on the 27th, we're nearly at 50 kilowatt hours of output. But on the 3rd of March, we're less than 10. So the weather plays a big role in the output of a PV system, particularly at this time of year. We have seen a significant increase in demand for batteries in the last 15 months, and that's been driven by the electricity price quadrupling in some areas. There's also the difference in the import versus the export rate. If you're being paid, say, 12 pence for what you export and you're 40 pence for what you buy in, if you're using power out of a battery, you've got to deduct the 12 pence because you're not exporting it, you're not getting paid for it. So you just need to be careful that that is taken into consideration. How much excess have you got? Other thing is to be careful of is, and this image on the right is from St. Paul's, where the battery, the only place to put it was outside, but we advised them to build around it a wooden pent-roofed hut, if you like, to protect the battery from freezing conditions. If any of you drive an electric vehicle or a hybrid plug-in electric, you will know that when it's really cold, your battery, your range suffers big time. the same is true of any form of battery for a PV system. They do tend to not operate properly once the temperature goes below 0. So just bear that in mind. Also, as you can see, the bottom 2 batteries on this it is a modular battery system. It starts at 5 kilowatts with a controller, and you can add further 5 kilowatt batteries. So remember that if you go for a modular system, you can add capacity in the future if you find that you are exporting more than you were. The usable capacity of a battery is always less than its kilowatt hour rating. If it says 10 kilowatts, it's all around about 90-ish%. So a 10 kilowatt battery is going to be around about 9.5 kilowatt hour actual usable. You can also charge them up if you have a TOU, a time of use tariff, if you've got cheaper overnight rates. But you need to look very carefully at the cost benefit analysis. They are still quite expensive batteries. But don't get me wrong, in the right environment, so with a reasonable sized PV system with things going on in the evening in the church or the church buildings that are connected to the supply, they can be a very good investment. If we just look at self-sufficiency here, what you got here, same church actually, quite interesting to see here, which is batteries always have to have a little bit of charge in them, which is the green line running along the bottom on the left-hand side of the chart. Interesting to see here that at about 3:30 at night, something is coming on in that church that is using a lot of power, and something's just after 6 o'clock is really spiking. But then you can see the yellow is the PV. You can see the PV generation as daylight comes, and then you can see that obviously apart from a few spikes on the load, where obviously something was being turned on that used a significant amount of electricity, you can see that the yellow is the PV is effectively helping, almost all of it is being used in the building, and the balance is going into the battery. So you can see the green chart, the green section of the chart is the battery charging up and then discharging. So it's actually keeping the building going. In this particular example, it's quite good. It goes up to 10 o'clock in the evening, and you can see the blue. So it's suppressing the requirement to draw from the grid, and that's how the battery works. It can be programmed to do slightly different things. So batteries, they have a potential to deliver a good benefit. The installed price, don't be fooled by it. It's not just the price of the batteries. A bit of cabling, they're quite expensive. They weigh an awful lot. You need several men to lift them up onto the wall, men or women. Single or three-phase supply, different types of battery systems for three-phase supply. Where's it going? Got to run cables. The battery always needs to see the grid. It absolutely needs to know. So it needs to know if the PV system is exporting, and the only way it can do that is by monitoring the outbound in there. And also there's monitoring, so you need data cables, so you can look at it over the web, and that's very useful. You can see exactly what the building's using, what the PV is generating, how much charge is in the battery, very useful. 10+ year manufacturer's guarantees. You can add a battery system to an existing system. And you can add one, you can put a system in, the PV system in today and add a battery in 2 years' time. Can easily be done. We've not heard of any issues with insurance, but it is worth checking your insurance. And I've given you a rough indication of the sort of price. It's also important to realize that the battery storage doesn't actually increase the carbon saving. All it does is, instead of it flowing out and being used by the street lights or whatever, you're using it. It doesn't actually increase the amount of CO2. So it is a financial benefit to the church in that it enables the church to be more self-sufficient. Okay, do you want me to go through case studies, or have we run out of time? I mean,
I'm a bit torn. It's 5 o'clock. People will want the case studies, but also we haven't answered any of the questions yet. I have a hard stop at 5:10. How are you set, Guy?
I'm fine, but I think some of the questions would probably be, I mean, I'm going to send you these slides anyway.
Yeah. Let's do it that way, because if people can see the case studies when they get your slides, and I'll also give them links through to our case studies page.
Okay,
so
what I can't see for some show navigator, right? What I
so
can't.
If I just say to everyone listening in, if you are able to stay until 5:10, please do give us a few extra minutes, and we'll try and answer a few of the questions at least. If you go into the Q&A, you can do thumbs up next to other people's questions. So
Right.
that'll help.
Okay.
Sorry, that wasn't addressed at you, Guy. That was addressed at the listeners. If you all go into the Q&A, you can do thumbs up next to the ones you're most interested in, and we'll try and tick off a few that get a lot of thumbs up. Right. Now, the very first question at the moment is about recommended installers. So if I grab that one, Parish Buying offers solar as a service. They've currently got 5 solar installers who have gone through their framework process. I will put the link to that in the chat. Other than that, I would
sorry, I'm just looking at the questions. The first one, Peter Reynolds.
Yeah, I was just answering that one, Guy.
Okay.
That one's coming my way.
Right.
So in terms of, does the Church of England have a list of recommended or approved consultants? So Parish Buying has done a framework exercise. There are 5 installers on there, and I put the link through in the chat. And other than that, what I would do is exactly what Guy recommended earlier, which is go to the MCS accredited list. I've already posted it in the chat once, but let me do it a second time. If you go through under the MCS, they have, you can search for installers and you can search for products. And is there anything you would add to that, Guy?
No, I think that's good. I think that's absolutely right. Go to the mcs.org website.
Right. Let's try and chunk. I'm going to rank them, Guy, by the order of upvotes. Don't worry. I'll tell you where we're on. So let's see if we can chunk through some of the ones. It says, if the meter is reliant on the internet, does the church have to have a good internet connection?
Right. The answer to that question is that we put, any installer will put in a hardwired meter. That is a physical meter. It's called the total generation meter. You can read it. You don't need the internet.
Okay.
Now, the internet, ideally, you can have, it can be Wi-Fi or it can be hardwired. But it's very useful. If you've got Wi-Fi, you can monitor the system over the internet, but you always have the fail-safe of the hardwired meter.
Great. The next question, now this is going to be on many people's minds. Are you aware of any churches which have had solar panels installed which are listed buildings and in a conservation area and where the roof is visible? So I know of ones where they've been partially visible from certain angles. What do you know of, Guy?
It's St. Augustine's. That's visible. It's on the chancel roof.
That's true.
I think there are some on your case studies page, aren't there? I'm pretty sure there's a grade listed church.
Oh.
It's not easy. I would say that it's not easy. It's not impossible. Yeah, I can't think of any off the top of my head that we've done. I mean, it depends what you describe as visible. Visible from the public highway is one thing. Visible from a block of flats 200 yards away is a completely different thing. But that is not normally refused. I've never heard of that being refused, although we've had one in the city where the solution was all black panels. But the honest answer to that is it's difficult, but it's not impossible. It's not impossible. For example, if there is a parapet, even if it's a balustraded parapet, and you're using all black panels on a slate roof, yeah, that might get through. It might well do. So can't promise, but it might do.
If you have a church hall nearby, can you link the PV supply to the hall rather than having to put panels on both? So if you had a church hall and a church, could you have one installation which is giving electricity to both buildings?
Yes, what we've done in the past, because, and I can't remember whether this was a church rule, but we put the solar panels on several churches on the church hall because it had a better roof, actually, and because it was easier to get consent. But it's actually wired back to the church supply, which is one of the reasons I was saying sometimes if you get a dual, sometimes we go into a church, got two supplies. For some reason, it's been added over the time. One of those supplies does part of the church, and it does the church hall and maybe a few other buildings. If they were consolidated into one, then you could put the solar panels on the church or the church hall and power the other buildings. So yes, you can do that.
Right. The next question is about putting solar panels on a lead roof. And it's not quite clear from the question whether the question is one about faculty, which I think you probably couldn't comment on, or whether it's actually about the practicalities of attaching solar panels.
Well, we're talking about
a
flat lead roof, or
I imagine not probably. I imagine it's your standard.
Well, we install on what's called a standing seam zinc roof, which is, and we have done some. There may be a special clamp. It has to have a raised seam. The answer. Anything that's more than 2 degrees is not considered a flat roof, and a flat roof mounting system in general is not acceptable. So it would have to be fixed into the roof. But if it's a standing seam, I believe there is a specific type of seam clamp that can be used.
And I've popped in the chat a link through to a case study of a copper roof, which talks about how they were attached to the roof.
Again, that's the stand. That would almost certainly be standing seam if it's copper, but they are a rather lovely colour. The verdigris colour.
Now, the next question is about solar slates. Are you aware of solar slates that mimic the look of slates and are PV panels? Yep, certainly well aware of them. If so, is their efficiency comparable to conventional PV panels because they may be more acceptable aesthetically?
The answer is they are less efficient. They don't perform as well, and they tend to be lower wattage. They do look better, but they are fearfully expensive. We've done a couple of them in the past, but there's only really one supplier of solar slates, and they were not MCS accredited for a while, but I believe they may be back now. If you're going to use solar slates, why don't you consider an in-roof all-black panel system? Because it's virtually the same, and it's significantly less expensive. But they do exist, and yeah, they do exist. It's not something that we generally use, to be honest with you. Okay.
I will. The church I have visited that has solar slates and that was done some goodly time ago was St. Silas Pentonville. So I'm just popping a link in through to their page about the project. Tim, I'm not sure if this is so much your area, Guy. Tim has said, I heard about zero capital cost solutions using loan or lease finance to get PV systems installed. How do we access these? I don't think you get involved in financing as products, do you?
Not really. This is something that when there was the feed-in tariff, it became very popular because there was a revenue stream, and that revenue stream, to some degree, some lenders were prepared to guarantee, would accept it, if you like, as a guarantee. But what they did is they effectively took your feed-in tariff income. It's not something that we get involved in, to be really honest with you. Yes, I'm sure a good financier could work out. I mean, it depends what your return on investment is ultimately at the end of the day. But if you're saving enough electricity to warrant paying off a loan, then fine. But it's not something that we have a huge amount of expertise in, if I'm honest.
Given right, how are we doing? Oh, it's 5:09. Forgive me.
That's okay.
I'm very conscious that there are unanswered questions, but I'm also very conscious that I have to finish at 5:10, or my daughter will be abandoned from where she needs to be picked up.
Okay.
So I'm going to have to bring us to a close then. I do hope everyone's found it useful.
I just answer one thing. which is somebody asked about three-phase supply to a church. Yes, that does work perfectly fine. It enables you to put on a larger system without having to get formal permission. Okay, so three-phase is absolutely fine.
Good to know.
And panels are self-ballasted on a flat roof. Okay.
Thank you. Guy, thank you so much. You've got too
Pleasure.
much wisdom to fit into the time. That's the problem. We could have sat here for another hour answering people's questions.
Well, you're very kind.
Thank you very
I hope
much
it was of use
for our
anyway.
session today. Everyone who's joined, thank you so much for coming. I will send you all the links from the chat. And Guy, if you're happy to send me over your updated slides, then
Yes,
I
I
will
will
send those out to everybody. It won't be until tomorrow now because I need to dash. Thank you.
And I've got a dash too, so I'll get you the slides over tomorrow.
Thank you everyone for coming, and I do hope to see you at future topics. Goodbye, everyone.
Okay, super. Thanks very much.